In this video, we'll go through an example of how to write out the quantum numbers for a particular atom. So our problem here is write out all four quantum numbers for the valence electrons in a nitrogen atom. This brings up a new term for us called valence electrons. And valence electrons are simply electrons in the outermost shell. And these are going to be the electrons past the noble gas configuration. Okay, so if we want to look at the electron configuration of nitrogen, it's going to be helium, 2s2, 2p3. So this atom is going to have 5 valence electrons. So we need to write out the quantum numbers for all 5 of these valence electrons. So when we draw the orbital block diagram, we need to put the 5 electrons in. So we're going to have 1, 2, 3, 4, 5. So here we have electron number 1 and electron number 2, electron number 3, number 4, and number 5. So here we can write out the 4 quantum numbers. We have the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. And we need to write those out for electron number 1, number 2, number 3, number 4, and number 5. The first electron is in a 2s orbital. So that's going to tell us the principal quantum number is 2, and the L quantum number is 0. So N is 2, L is 0. For an s orbital, our m sub L is going to be 0. Because remember, m sub L ranges from plus L to minus L. So this is going to be 0. And here we have a spin up electron, so it is going to give an m sub s value of plus 1/2. Okay, so this tells us exactly where in a particular orbital our electron is and what spin it has. The only difference between electron number 1 and electron number 2 here is the spin. We're in the same subshell, we're in the same orbital, we're in the same spot in that orbital. The only thing that's different is the spin. Okay, so from electron number 1 to electron number 2, the only thing that really changes in here is in the spin. So now when we look at electrons 3, 4, and 5, they're going to have the same exact principal quantum number. Okay, because they're in the same subshell. We have a 2p orbital here. We're in a p orbital. So remember that the L quantum number is always going to be 1 for the p orbitals. So each of these is going to have an L value of 1. Each of these electrons are all spin up. So we're going to have a plus 1/2 spin for each of these 3 electrons. The difference is, and the only distinction, is where in that p orbital these electrons are. Okay, so if we look at the m sub L values, remember they can range from plus L to minus L. For a p orbital, L is 1, so they range from plus 1 to minus 1. And this is going to be the different distinction between these 3 electrons, because they are located in a different block of that p orbital. So the 3 values we'll have to write here are going to be plus 1, 0, and minus 1. So If we only had 3 quantum numbers, we wouldn't be able to distinguish all of the electrons. So we need 4 identifiers to figure out where each of those electrons are going to, or we need 4 identifiers to give each electron a different set of 4 quantum numbers.